Hi, my name is Ijeoma. I'm going to be kicking off this presentation on behalf of my team, Alejandro, Gabriel, Mohammed, and Korang. For this presentation, we're going to be showcasing our workflow process for identifying drilled but uncompleted wells in Alberta, Saskatchewan, and British Columbia. We're also going to be showcasing our app that we created for this purpose. So I'm going to jump right into the code. So to determine whether our well was a dock well or a non-dock well, these were the checkpoints that we followed. So in general, we first of all checked the current status of the well, and we also looked to see if it had any perf or production data. And if it did not have any production record, we also checked to see if it had any completion records such as perforation or well stimulation. Once we completed that, we're able to come up with a list of dock wells versus non-dock wells. So using these Python scripts that we created, we're able to filter out the wells we believe to be dock wells, and we ended up with a list of 18 wells. So our next step, we wanted to determine how long these dock wells had gone uncompleted. To do that, we assumed the baseline of the latest production period from the entire production data set. We use that to calculate our days of uncompleted status. So using this information, we're able to create a histogram showing us a range of the values for days of uncompleted status for all the dock wells. To provide better insight, we decided to create bins for the days of uncompleted status, starting from as little as 0 to 60 days all the way to 3 years. And as we can see, for all the dock wells, 90 to 365 days is the most common range. So to provide more insight, we decided to also check on the dock status duration for non-dock wells. So to do that, we assume the dock status end date for all of the wells to be either the first production period, or in a case where that information was not available, the latest activity date. So to calculate the days of uncompleted status for the non-dock wells, we subtracted the unique rig release date for those wells from its unique dock status end date. So here we created a histogram for the dock duration status for all the non-dock wells to be able to show us a distribution and also the range of those values. And now I'm going to hand over to Alejandro to showcase our app.
Thank you, Ijeoma. So Docker Node is a functional prototype app that allows the user to perform EDA and dock well identification online. This information could allow services companies to identify possible clients and forecast market sizes. The app can be found in dockernode.herocoapp.com. So first of all, what is a doc? So this is the documentation of the app where we show all the strategy and the workflow diagram that Ijeoma explained before. In the EDA tab, you can see the most relevant features of the dataset, as well as a visualization where you can see the localization of the walls and interactive graph of the whole dataset. So you can do something like day drilling, and then the app is going to change dynamically with your choice. You have as well analysis for production when we join data from the well header and the production table, and we can have total production and average production by different information, or let's say by province, and then the app automatically give you that information. We have as well information for perforation treatments, which are different kind of treatments, the frequency of the treatments per well, as well as the most common activities. And you can select, let's say, top 4 activities, and you have the 4 top. Now let's move to the Datathon identification. So based on our criteria, we have found a total of 18 dogs. This is the general information for the dogs, as well as the location in geographical location. You can go interactively with the app and see what is the identification of the wall, the formation, and the current operator. We give this interactive graph as well to provide to the service companies relevant information, so the current operator by field and the number. You can go individually by well, just select the ID, and then you are gonna have the information of that one. We present here time analysis, how long every dog what has been without producing, and we bind by different time periods. As well, for the rest of the wells, we analyze how long they were dogs at some time. So it seems like around 100 days is the most common, and we have the breakdown here by formation and more interactive graph, so you can play with that. We have even more information in dashboard. So, for example, we have by current operator how many dog wells there are and how long they have been dogs, and you can change this easily by different kinds of formation. This is just one formation for this uh, data set. So let's move to prediction. The prediction is the part of the app where we add a really good value, because in 6 months, 1 year, when the data base has been updated with new words, you can see if it's their dog or not. You can just upload the new files in this section. So we have the header, we have the production information, and we have the treatment information, and then the app is going to give you the new insight. So in this case, you have two dog walls, and that inside can show you the location and the same capabilities as showed before. You have the time analysis and the dog duration, and the nice thing is you can even perform EDA of that new analysis, showing you the header and the, let's say, perfect treatment in that as well. So this is where this app really shines, and this is how this app is gonna let you to identify if a wall is dog or not. Thank you.